The topic today is prefab passive house, or prefabulous, we like to say. Prefab passive house is near and dear to my heart, and also my consulting and design build practice. I've worked with 2 or 3 speakers here today, and all are forging a path in this niche in their own unique way. What do we mean by prefabricated buildings? In general terms, these are buildings that are manufactured off-site, usually in standard sections that can be easily shipped or assembled. In our discussion today, we're focusing on prefab consisting of components, for example, panels or modules, like modular homes. These are distinguished from manufactured homes, which come in large transportable sections built on steel beams, things like that, or mobile homes or trailers, which are built on wheels and can be moved. There's often the stigma in North America, for sure. We were talking about and mobile homes, how they have given prefabricated homes a bad name. In Europe, of course, it's a different story. Many homes, a large percentage of homes are built prefabricated in Scandinavia and throughout. So prefabrication has been around for a long time. Back in the 1800s, prefabricated houses were imported from the UK to Australia during colonization. The UK built over 150,000 prefabricated homes between 1945 and 1948 after the war. And in the US, even Sears sold mail-order kit homes through their catalogs. And that was back as far as 1902, 1910, that kind of thing. So today we have a distinguished group of speakers. Just a bit of housekeeping. I just wanted to, we're going to keep the questions until the end, but please feel free to type your questions into the bar on your GoToWebinar screen. I hope everybody can see that. If you have a specific question for a specific presenter, then just write down the name, and what I'll do is I'll read them out at the end and get the presenters to answer those questions. So first up, we have a presentation by Adam Cohen of Passive Structures. His title is called Build Smart North America. It's bringing affordable and accessible passive house to all. I think Adam just came back from Passive House Conference in Germany, where he presented a similar topic. Adam hardly needs any introduction. He is a leading expert in North America in passive house. He's a practitioner. He's a teacher. He is also sought after for conferences across North America and into Europe, of course. So I'm going to pass it over to Adam, and we'll let you start your presentation, Adam.
Okay, very good. Thanks. And thanks everybody for being here and for allowing me to do this. I've been a Passive Buildings Canada member for now, I guess, going on close to 4 years. I am, even though I lived in the States, I have a strong belief that Canada should be leading North America in the passive house movement for a number of reasons, not least of which is that you actually have a growing country with a relatively decent economy. And so what I'm presenting today is Build Smart North America, which is a result of 6 years of work that I have through my design build business. So what we're going to do is we're going to talk a little bit about Build Smart. I'm going to show some examples of delivered projects, talk quickly about the passive technology, talk about the systems we've created, and then working with the systems. So our mission at Build Smart is to produce standard manufactured components that will facilitate market rate, high performance buildings, market rate meaning the cost of construction. And we're concentrating basically in any building sector in North America. We formed in 2009. We're a vertically integrated triple bottom line company, and we manufacture all our components for the low energy buildings, and we're doing it in such a way that we can deliver these buildings at cost parity with standard construction. I'm the founder, and I am a kind of a thought leader in the North American market. We are founding this on my experience of consistently delivering now 12 projects at market rate. And our system is very simple. It uses very common North American materials, nothing strange, nothing weird, and the only thing is that we're using these materials in very simple, innovative ways. And our engineering is based on the proven European passive house technology. So this being a passive builder group, we don't have to sell anybody on anything. So as an example, this project here that you're seeing, this won the National Association of Home Builders Green Home of the Year in 2013. It was called Mainstream Green. It was delivered for less than $150 a square foot, and it operated on less than $50 a month in energy. Now, what is it aimed at? What does cost parity mean? Well, most North American families have a mortgage every month, and then they have a second mortgage, which is their energy bill. If you ask a North American family, which one of your two mortgages are you not going to pay, they're going to say, I only have one mortgage. You say, wait a second, do you pay an energy bill every month? And I say, absolutely, yes, they do. Would you not pay it? No, we want to have lights. Then you have two mortgages. So your monthly cost of ownership is the same. But we ask you a question. Would you rather buy an electron and then a second later buy more electrons and a second later buy more electrons, or would you rather take some of that money and put it into equity in your mortgage? When we put it that way, all of a sudden it becomes a no-brainer and people start really moving over. We've basically been able to move all our clients into passive houses for no monthly extra cost. Now here's some examples of two houses. This one on the left is a 2,200 square foot standard house, and the one on the right is the one that I just showed. Both of these projects were monitored for 13 and 14 months. They both came in below the predicted value. They were both built for less than $150 a square foot, and all of them operated on $1.50 or less a day in total energy. And all of these, this included pump energy. These are on wells. So affordability, performance, proven. Now, don't think you can only build boxes. Here's a couple of other projects that we have built. These are $2 million passive houses, and you can see they're highly customized. So the system that we've created can also be used for these highly customized projects. So in commercial projects, here's an example of some of the stuff that we've been doing. This is the first U.S. passive house public school. It was LEED Platinum. It was built for a market rate of $155 a square foot. Its energy use has been 68% below code, and it's been energy positive for the last 4 years. This is the Malcolm Rosenberg Center for Jewish Life, or the Hillel at Virginia Tech in Virginia, Blacksburg, Virginia. It's the first passive house assembly building in the U.S. It was built for market rate at $135 a square foot, and the energy use was 75% below code. This is Hickory Hall Dormitory, which is currently the largest passive house building in occupation. It's we are now working on two that will replace this. We're working on a 100,000 square foot multifamily in Boston and a 300,000 square foot multifamily in Kansas City. So this little guy here that's 50,000 square feet will be replaced pretty quickly. This was built at market rate of 118 a square foot and 74% below code. And lastly, this dental clinic was built for a market rate of 155 a foot and 65% below code. So you can see this does not just apply to residential, it applies to commercial construction too. So where did we get passive building? I'm just going to go through this quickly since you all know this. It's based on our North American experiences in the 70s. Then the concept was taken over to Europe in the late 80s, and Dr. Feist and Professor Adamson figured out, how to do this in the correct way, how to super insulate without the problems. They built their first optimized passive house in 1990. There have been 40,000 plus units delivered since. And, as you know, it results in a 60 to 70% overall energy savings and 90 to 90% reduction in heating and cooling energy. In 2009, the EU directed that all buildings by the year 2018 be built in the passive house level of energy efficiency or better, because it was verifiable, it was repeatable, and it was affordable. So using that, how do we do that? You guys know this. I'm not going to go through. I'm just going to go quickly. We minimize losses through the envelope, through increased insulation, airtightness, and thermal bridge-free insulation, making it a fabric-first approach. We then balance and maximize our glazing, shading, passive ventilation, and interior heat gains. And lastly, we layer our high-performance systems on top of that. So now the trick is, as we all know, to make this something that is affordable. Now, how do we do this? Well, we start thinking about modular systems. And we're not talking about modular like you bring it as a box to the site. We're talking about modular pieces that you can put together in lots of different designs. So we've created slab foundations, modular systems. We've created precast basement systems that are in modular form. And when I say modular, I mean components are modular. So the pieces and parts are modular, and they can be built for anything. And then probably our biggest innovation are these wall forms here. You can see here the picture in the factory of us delivering the walls. They're standard American built stud walls. We're very comfortable with this in Canada too. You can see here we delivered the house on a truck. Here's Jim setting the first corner on the house. Here's the house 4 days later testing out at 0.45 air changes, and here it is finished. They require basic carpentry skills that all North American carpenters possess. They know how to set a wall panel. We can set it in an airtight way. They require less labor and allow us a faster construction time. The other thing that's really cool about the system that we've created is that it's a simple system. It's modular in terms of dimension. It's also modular in terms of R value. So without changing any tooling or equipment, we can build from desert to Arctic assemblies. So our standard systems are a slab, where we have a slab form that's high durability, I want to say, but it's a compact foam that is termite treated. You put that in, pour your slab, deliver the walls, snap, 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 and there you go. You've got a house. The basement systems, you put the precast basement in. One day the basements are in. The next day you put up the floors, put on the walls. Next day, next floor, and the roof. Now, the really cool part about this is, as any North American builder will be comfortable with it, because when you walk inside, what you see is an open stud cavity wall that's ready for your electrician and your plumber and your HVAC guy and your insulator to come in. You don't have to learn any new skills with this. You don't have to, think this is some weird European, low energy building. This looks just like any North American building, built with studs and framing and et cetera, et cetera. So we've tried to hit our North American market right squarely where it understands how to build. So we have two systems. We have a standard system, and this system is really the system that I think is record and groundbreaking. I was inspired by Henry Ford's, you can have any color car as long as it's black. We kind of took that and said any color as long as it's white. This system is a very simple system. It comes in 8 and 9 foot heights. We've created 6 basic building blocks in straight panels: 1 foot, 2 foot, 3 foot, 4 foot, 6 foot, and 8 foot straight panels. We've created 2 foot inside and 2 foot outside corner. Those are all the modules we have, just those 8 modules to start out with. Then we've chosen 3 single windows, 3 single doors, and 3 twin windows as our basic building blocks. The windows are white PVC, any color as long as they're white. The doors are white aluminum with wood on the interior. Now, we are buying these in bulk, and we are taking away the fear factor or the reluctance to order from Europe. We are pulling them in bulk. We have factory-trained technicians on staff, and we are pre-installing these in the insulated wall assembly, and they're also pre-airtighted. So you receive the panel, you put it on your plate, you set it, and the window is already in the wall. It's already airtighted. So this is an incredibly affordable system. What we're finding is that on single family, we are between $15 and $30 a square foot of floor area for the delivered assembly. Now, On larger commercial projects, 4-story multifamilies that are 40, 50,000 square feet, we're finding that to be more like $10 to $12. Now, one of the things we've done is we've looked at how do we get away with how do we bring the cost down, and we've done that by getting rid of all non-value added activities associated with this. So we don't have any shop drawings because we've standardized everything. We don't have any measuring to do in the factory. All our components, all our pieces and parts are pre-cut and jigged to reduce production time. The EU windows and doors, we've simplified the purchase, so no longer do you have to go buy a certified Passive House window in the EU. You're just buying them direct from us, which we stock in our showroom. And we are delivering them installed and airtight. This standard system can be used in multiple different ways that I'll show you. Now, we also have a custom system. The $2 million houses I showed you was using the custom systems. We can do any height, any configuration, any Passive House certified window or door that's made by Munster Joinery in Ireland. Is it affordable? You have to ask yourself that question. What we find is that it's between $40 to $60 per square foot of floor area. So it's 2 to 3 times as expensive as the standard system. For one thing, you have to put shop drawings. This is a project that Bill McDonough's office designed and we built. You can see here a very modern house with 65-degree angles and all kinds of 12-foot walls, some pretty wild fenestration. But this is a very time-consuming and expensive thing to do, but we can build anything. All the components have to be custom cut and laid out. All the doors have to be and windows have to be ordered. We can't get the kind of discounts we get by ordering container loads of those just simple windows and doors. So when we can, we deliver these installed and airtight. So you can see here, this is one of Bill McDonough's, the panels from Bill McDonough's house. This is one of the 65-degree angles. The window's pre-installed. It's getting ready to be set there. So how do you work with it? There's 3 ways you can work with it. The first way is just by drawing, right? If you're a designer, you can just lay out the exterior walls. Everything works on a 1-foot module. So you use even dimensions. We always recommend to use 2-foot, but 1 foot works fine. Then the first thing we do is we snap in our corner pieces. So we snap in our corner pieces. Then we put our exterior wall elements that you'll need. So this is an infill house in Pittsburgh, Pennsylvania. In this house, we know the front facade will have a front door on a front porch, and we also know that the front facade will have a twin window centered in the dining room. So we snap those pieces in. Those are the knowns that we have. Then, step 3, we just finish the interior layout. Step 4, now that we have the interior layout, is we just fit our panels to the interior layout to get it to work. This house worked out to $24.35 a square foot for the component panels, including bands, foundation system, and windows and doors. Now, here's the second way you can work with it. You can take an existing model like this. This is a production home in Delaware that's using our system. This was their initial design that they've been building forever. They sent it to us. We did what we call an initial fit, where we fit it to our panels, and then our CAD system automatically does all our takeoffs and pricing, and there you go. There's the house kind of reconfigured for the panels using all standard panels. Then the last way, which is probably the easiest way, would be you send us an email, we send you a link to a Dropbox, and you download SketchUp components. We have all the components modeled in SketchUp. Step 2, design your project using the SketchUp components. Step 3, send us back the design, and we will send you back a price. And here it is. These are infill projects in Philadelphia, and if you look down there, $25.85 a square foot. $70,000, that's for the entire Passive House fabric. So, this system really is designed to make it easy, simple, and affordable for Passive House to come into the mainstream. So, the other thing that we are developing currently in BuildSmart is we're developing a conditioning energy recovery ventilator that has smart controls. It will provide dehumidification, heating, cooling, air exchange, and maximization of low energy. It's got smart controls that if it can just, it's got a water-to-water heat pump that's got a COP of 6, but it's so smart that it knows when it doesn't even need to circulate, when it can just circulate the water and not turn on the heat pump. So sometimes we're just leveraging the water temperature to heat and cool, and if we need to, we then will use the compressor and turn on the heat pump. We are also working on low voltage lighting systems and monitoring control systems. So that is Build Smart.
Our next speaker is Lydia Hunter, and Lydia comes from the West Coast, from British Columbia. She graduated from UBC with a degree in environmental geography, and she currently works with BC Passive House, a manufacturing company prefabricating panelized systems to meet the Passive House standard.
So, as he mentioned, I worked for BC Passive House. I also worked for Durfeld Constructors, which is a general contracting company out of Whistler, and BC Passive House is now based out of Pemberton in British Columbia. Our company was first introduced to the Passive House standard and the idea of panelization with our work on the Olympic Austria House. This is a project that was built for the Olympics by 5 companies out of Austria, 5 private companies, using the global stage of the Olympics to showcase the Passive House standard and their different components. So we acted as a general contractor on the Canadian side, but the majority of the project was manufactured in Europe, shipped over, and assembled here. So as a builder, architect, and consumer, we are faced with numerous green building standards on the market today. Each one has a different application process, qualifies for different incentives, and requires a different approving body. The Passive House standard is no different, but what set it apart for us was that the approach made sense and the results were undeniable. They have been monitoring the energy usage for heating and cooling and domestic hot water for the Austria House since construction, and it averages between $230 and $280 per year for heating, cooling, and hot water. This is now a building that has been gifted to the municipality of Whistler. It's public use. The door is open and closed all winter long, and those are the heating bills. So after the Olympics, we were left with this legacy and a corporate responsibility to rethink our building practices. We worked with a number of different experts both in Canada and Europe to develop a panelized system that would meet the Passive House standard. At this time, Passive House was still relatively unheard of in Canada, and the Austria House was actually the first Passive House in Canada, and as well as the idea of panelized construction. So no one was knocking down on our door to order these panels that we had just designed and developed. So we developed a pilot project, the Rainbow Passive House, to showcase the system and demonstrate both to ourselves and to the building community that we could meet the standard for an affordable cost. This project was actually built to the Whistler's price-restricted housing initiative, so it was very budget-driven. It was through this project that we landed our second job and our third job and so on. Since the Rainbow House, we have provided envelope systems for 7 more residential homes across the province of British Columbia, as well as roof panels for 2 large commercial projects. We had developed enough of a market to invest in a new facility that we constructed in Pemberton last year. It opened in June. Just a little note, the conference area and office rooms, which are upstairs that you can't see, were actually built to the Passive House standard as well. So why was prefabrication attractive to us? Most importantly, you are controlling your building environment. So you are building out of the weather, eliminating additional work that's associated with dealing with the weather, as well as it protects materials from swelling, warping, mold, and so on. It also allows you to build on a flat square surface with different levels of automation and access to tools that you wouldn't typically have on a job site, increasing your efficiency. It also leads to the opportunity for greater precision and quality control than is often afforded on site, and also allows you to decrease your construction waste by optimizing your material orders. You also dramatically decrease your on-site construction time, where most of our projects average between 1.5 to 6 days to get out of the weather, and you can be constructing the panels while the contractor is doing the foundation on site. So when we were designing our system, we wanted to come up with something that would work in the Canadian market, that would be affordable, and that focused on using sustainable materials as well. So the idea was that we wanted kind of a natural recyclable at the end of its lifespan build up. So we took a wood first approach. What we came up with was typically, especially if you're going to the passive house standard, a double wall system. So the insulation wall, can you guys see the mouse on when I move it? The insulation wall,
Yes.
if you can,
Yes.
is what we typically manufacture or prefabricate in the plant. This is standard stud framing, and we have the opportunity to also apply siding in the plant, but that depends on what siding you're using and how well it travels. For the wall, again, we use stud framing. We have OSB as our interior air and vapor barrier, and we use a wood fiber diffusion board on the exterior. For if you are using a floor package, and the roof packages will use a TGI system. On site, the local contractor will install the service wall, and this is a non-structural wall that goes up very fast, and once the services have been run, it is insulated, and then your finishing material is applied on top of that. Very important, and I will touch on this on the next slide as well. This is a vapor diffusion open system, so we do need to have vented roof space as well as a rain screen on the exterior. So as I mentioned, it is designed obviously to be airtight to meet the passive house standard, but also vapor diffusion open. So we have OSB as our interior air and vapor barrier. We chose OSB because it is very strong and durable and very difficult to damage. So during the construction process, you don't run the risk of accidentally puncturing holes into it. We located it at the interior sheathing where it's closer to the warm, moist air and therefore less susceptible to condensation. All of the panel connections and any penetrations to the OSB are taped with high-performance building tapes such as SIGA to create and maintain that airtight barrier. On the exterior sheathing, we had a wood fiber moisture resistant diffusion board that is about 25 times more open to vapor diffusion. So this creates a system that will naturally ventilate excess vapor to the exterior while blocking weather from the exterior. So your envelope essentially functions like a Gore-Tex jacket, allowing your sweat out while blocking rain on the exterior. So with prefabrication, we start the process with a design review with the engineer, architect, and potentially the general contractor for the project. So we, in comparison to Adam, are for the custom home. And this is very important that we have these meetings because we can find efficiencies within the design from that initial meeting and set out the panels that way. We have found that for high performance buildings, the design and execution needs to be a collaboration from the beginning. Everybody needs to be on board, the engineer, the architect, the contractor, building officials, and subtrades. They need to have a clear understanding of the project goals and how to go about meeting these goals in a cost-effective manner. This is especially true when prefabrication is involved, as many of the decisions need to be made before construction can begin. Just to touch quickly on having the building officials on board, again, panelization is still fairly new as an idea in building in Canada, and it's important to have that initial discussion with your building officials to make sure that they are on board with the process that you have all you will need for the approvals, and that they are satisfied with everything. This will help prevent any delays later on. So, oh, sorry, it's not moving forward again. So from here we start shop drawings. As I mentioned, we custom design the panels to the architecture and engineer drawings, giving us freedom and flexibility in the products that we supply. We use CADWorks to do the design, and it's a 3D and 2D drawing program. And this program is hooked up to our machinery in the plant, so we can have that optimization with material orders and cutting. This right here is a simplified 3D version of a recent project that we just did. It kind of gives you an idea of how the panels are broken up. The panels are numbered to simplify the construction process for the shop manufacturers, and then essentially go together like a puzzle on site. This is an exploded version of the same picture showing all of the panels in the house. For this project there were more than 100 panels built, including exterior walls, roof and floors, middle floors, shear walls, and garage walls. This way the house could be set up in one continuous stream, maximizing the use of the time, or optimizing the use of the crane. Another benefit of shop drawings, especially for projects like this one that are a bit bigger and more complex, is that you can take away different components of the panels in the drawing program that allow you to see any potential issues with bringing your services in, or any structural issues, and you can identify them prior to manufacturing and design accordingly. This is just a 2D example of what the crew actually uses to manufacture the panels on the floor. As we are only a sub-trade in the building process, we work with the general contractor on site, and we will produce the shop drawings for the foundation as well. This simplifies the work for the concrete contractor, and it also ensures that the foundation will be 100% accurate, which is very important when you're flying in prefabricated panels. From here we move to the manufacturing. This is one of our framing tables that allows everything to be built very accurately. They have a 5mm allowance that they work within, and again you can see we are not building outside in the rain, which is a problem on the West Coast. This is just a shot from our plant showing the panels for that project that we had the CADWork drawings for, set up and ready to be shipped to site. As you can see, the stack can get quite large. When they are put on the truck, they're put in an order that works for on-site assembly, and this is an example of a truck for a project that we sent up to Fort St. John, just showing how everything gets stacked in. So on-site with setup, as I mentioned, we average between 1.5 and 6 days. This project was out of the weather within 6 days. As you can see up here, this is a crawl space. These walls were constructed on-site, and the passive envelope starts with the floor down here. This is our insulated floor package. The weather was beautiful, and this is typically something that you would look for when you are doing setup of these systems. We can handle light to moderate rain and have the ability to tarp and protect things if it does end up with a downpour. But ideally, if you can find a short window of nicer weather, it just makes things go easier. The panels are dropped into place and sealed to prevent air and moisture penetration. And again, there is that 5mm allowance, so everything kind of just snaps together for that airtight seal. Upon completion, we immediately cover the roof with a breathable waterproof membrane. that the vented airspace will be built on top of that. For the sidewalls, we use something similar to Tyvek as additional protection. The wood diffusion fiberboard that we use on the exterior can be exposed to the weather when standing vertically for 3 months, and then they suggest that you should have your siding on by then. During this setup, if possible, we like to have the windows on site as well, and we place the windows on the floor that they should be or the room that they should be in during the process. With these large windows, that ends up saving a lot of heavy lifting when you go to install the windows. Some of the different features that we use when meeting the Passive House standard is we want to reduce our thermal bridging. So we avoid cantilevering exterior elements through the passive envelope, and we achieve this by including blocking in the exterior walls and fastening the glue lams with either Pitzel or Sherpa fasteners. We also use knee braces or vertical support posts to carry a significant part of the load. This is a glue lam going in. This isn't actually part of the passive envelope, but you get the idea of how we achieve that. We also try to bring the structural elements to the interior of the insulation wall, as well as prevent any of the structural envelope elements from going from the interior to the exterior by building the elements into pockets into the wall that can then be thermally broken. Airtightness, obviously an important part of meeting the Passive House standard. And before we even swing our first hammer, we have a servicing plan for each of our projects. We bring services in through pre-framed holes in the walls that once the services are brought in and run through the service wall, that gets insulated and sealed again. As you can see, obviously every penetration, panel connection, and so on is sealed with the high-performance tapes. And everyone that comes into the house, such as subtrades or contractors, are instructed on how to finish their construction process without compromising the airtight barrier. This is a close-up of the panels going in. You can see here that the panels are connected using a plus and minus system. We use a rubber gasket in between the panels to create a more airtight seal, and at some of the critical panel connections we also use acoustical caulking. You will also see in between the panels we have insulation between the connectors. Any unplanned or penetrations that don't come through the predetermined ports are sealed with Passive House rated tapes once they've gone through. This is common for plumbing vents, dryer vents, mini split lines, electrical, exterior electrical outlets, and so on. It's with this approach that our projects can achieve on average between 0.25 and 0.3 with the blower door test, which is extremely tight. And I think I might have spoken a little bit fast, but we don't see this as a solution for just residential projects. We see an application for prefab, panelized, high-performance systems for large-scale commercial buildings, and have started construction on a few of those, as well as multi-story buildings. And this is a direction that the company will be going in the next little while. And that is all I have.
Well, thank you very much, Lydia. That was very interesting. I think we had a comment here that that summed this up quite well, actually. It was a good mix between mass market versus mass customization. And that was a comment by Eric Bjorsen, who says that he's building his first passive house this summer using prefab. So that's great.
Could I actually make a comment with pricing and things like that?
Oh, yes.
although we are customized, and we have found that when you compare to standard regular stick frame construction, we are only about 10 to 20% more for just the framing package compared to your regular code-built stick frame on site, which that's depending on where you're building, but that is extremely competitive when you consider the benefits that you also get.
So yeah, I'm Hans, and I have probably the longest title here for this presentation, and I actually want to switch it over to lean passive house prefabrication pretty much. So who's this guy? That's me, born in Berlin, grew up pretty much all over the world. This is me actually as a child in Africa, and I came to Canada only to travel even more so, and then ended up just looking for more of a purpose in life, you know, that just, other than just, you know, sustaining myself. I went into the solar industry and was building very large solar plants. This one, in 2012, it was actually 700,000 panels on 3 sites. Didn't like how the government is, you know, playing ball with this whole thing, this whole industry, and figured, you know, we know how to make green power. We really need to preserve some resources, and that's when I came upon the passive house standard, and was kind of looking around, you know, what is going on in Ontario here. It's a very slow market. There's a lot of interest, and I just kind of was trying to figure out how could I be part of this. So I'm by far the newest of the group of us 3 here, the least experienced, and I started selling building supplies specifically for the high performance market, focusing also on healthy homes. I teamed up with Tom Gameshi from 50 Building Solutions out in BC, and we can now cover the majority of Canada with our supplies. Yeah, you will actually see quite a few pictures from his projects ongoing in this presentation. So yeah, that's the macro. Now let's go into micro. You know, prefabrication. I always ask the question: would you rather build or would you bet on this guy to build you the high performance car, or this team? And I'm pretty sure that we'd all bet on this one, although this guy may have more fun doing this. For some reason in North America, bigger is always better, so we call it high performance, whereas in Europe we call it minimal energy homes. And yeah, it's just what we run with. It is all focused on just reducing energy. Obviously this is a regular construction site that you know, and it has some inherent issues with it. You know, everyone knows the regular tools, the regular methods. You lay it over your feet, go for it. This is one of my favorite ones. I was actually a part of a framing crew, and we accidentally set a wall 3 inches in the wrong spot, and there was just no other way to really go about it than to just use a sledgehammer and bang this thing into place. Obviously there's issues with weatherization as well. Yeah, I just want to just kind of apply or get into lean manufacturing techniques, and which is a great way to really reduce waste. And so the 8 deadly wastes or deadly sins of waste are overproduction, overprocessing, excess inventory, defects, transportation, wasted motion, waiting time, and unused employee genius. The interesting one I actually find is wasted motion, because no one generally thinks about someone being wasteful with their motion. Obviously, all this waste increases cost. And we are, as Adam and Lydia mentioned before, all trying to do this within reason. We don't have generally the luxury of customers that are just going to waste their money. So I'm just going to quickly take you through some slides here of a project that was erected in Alberta by Tom Namishi at 5th C. Here are just some hand-drawn drawings of the owner of the house. Very simple layout with a workshop right next to it, and that was then transferred into CAD work, where you can really work out all the kinks and all the details of how this is all going to line up. From there, here's a corner detail. From CAD work, you can directly transfer the information without actually having to print this out to machinery. This is the machinery that Lydia was also talking about. This is in a job shop. They're very common in Europe, these job shops where you can send your information to and they will do the cutting for you. Here you have to look a bit further, but they are available. And so this shows that shop. You can see some of the lumber being cut on a speed cut by Hundegger. And this is the components that we end up with. They're all labeled. You can see miter cuts on them, and compound miter cuts. Here again, we see some more studs and all those components. So Adam was talking about his projects on how they create these modules that are standardized. Lydia was talking about walls that are prefabricated. We actually can take it one step further, depending on the situation. Sometimes we will actually just deliver the pre-cut materials on site. If let's say the job site doesn't allow for modules to be efficiently flown into the job site, it may actually be advantageous to just ship the components separately. I kind of compared. I say it's Lego versus Playmobil. Playmobil has the modules. Lego, you go into smaller parts. You still get the accuracy of this machinery. Yeah. So here is a truck of pre-cut components leaving for the job site, and this is the scenario where well, it could have been possible to bring the modules up on the hill. In this case, it seemed to be better off to, was more financially viable to not have the crane there sitting there. It could have possibly also been due to you're blocking the entire street with that crane. You really got to just get this out of the way and get it over with. The next one, again, this is going away from just pre-cutting the components and shipping them on site. This is now pre-panelized, and yeah, it shows that it is very fancy and very nice to be in a shop that Lydia is working at, but this is in a very simple barn where this gets pre-assembled. In this case, insulation, rock salt gets added. Blown insulation can also be dealt with. Yeah, and it gets loaded up. Here's the first module going in Alberta. This was actually pre-assembled in BC and then assembled in Alberta. Here you see this building coming together, and this here, yeah, the walls, the roof was assembled on the ground and then landed on top. There's a little bit of a detail photo there that shows, the accuracy with which that the entire roof gets landed on the walls. There is the building pre-windows. This was standing after 7 days. Not quite as fast as Adam Cohen and Lydia were talking about. Still faster than most, than what we see most commonly here, the windows going in. Oh, and another advantage of using CAD work is that you can actually drop all the information into Total Station, and you can shoot out your exact points. You can survey your points before you start fabrication, and you can then also shoot out the points at the end when you're landing this. And Lydia was showing the foundation. You can now ensure that you are landing that exactly on the foundation where it was planned to go. So I'm just going to quickly run down the advantages. You can work with much tighter tolerances. Tolerances in this case are not just an accumulation of inaccuracies, but you can actually, aim for it. As Lydia was mentioning, the 5 millimeter that they work with. You can be a lot more resourceful. The machinery can figure out how to cut those studs for you with minimal offcuts, reducing cost that way, which brings us, to those lean manufacturing guidelines again. We also use higher material quality. The machines that do the automated cutting generally don't use the standard quality materials that we find here in the market. They use SS structural components, structurally rated lumber, and that means we don't deal with twisted wood. Again, this in combination with the straight cuts just makes for a much more solid, solidly built envelope that will last longer. I think Rob was quickly cutting on or mentioning the longevity of these buildings, and that's obviously very important for sustainability. Higher accuracy, well, tolerance and accuracy are working somewhat together. You can structure the workflow much more than just having a carpenter on site. You can think this through beforehand before you get there. Better purchasing. You can, for instance, the windows are always an issue, and Adam was talking about that. Is commonly in construction, as most of you know, the window often gets ordered when the window has just been framed in, or the rough opening has been framed in, and now you would be waiting for high performance building. You're going to be waiting for another 8 to 12 weeks for your windows to come in. You really want to close that down. If you do have the luxury of accurate pre-planning, you can now order the windows long before you're actually starting to prefabricate, and know that this will fit down the road, and you can still meet your passive house requirements. Detailed drawings, you can work with a local crew that can assemble this. You're just going to guide them through how this is going to be assembled, and you can achieve those high requirements of passive house. Lower your labor cost. That is because things just going faster, just more fun. We also deal with some buildings here in Quebec. Labor cost is extremely high on-site in Quebec, and if you prefabricate this before you bring it there, you are just going to cut cost at the end. And also you have a chance to really improve on what you've done in the past, so you don't leave that up to chance. It's not in some carpenter's head, but you can actually really work on the mistakes that you found on past buildings and improve on it.